my dear grade 7 learners, I am teacher Demi. Join me as we explore the wondrous nature of science. Today, we are about to embark on an exciting adventure into the realm of mixtures and the incredible methods scientists use to separate them. Imagine having a mixture of different substances. How can we untangle them and reveal their individual components? Today, we'll explore several methods of separating mixtures. So buckle up for this exploration. Think about a time when you had to separate different things mixed together. Maybe you've faced challenges like picking toys out of a box or finding ways to separate muddy water. Today, we are going to explore methods that scientists use to separate mixtures, plus their application in our daily lives that we unknowingly use. But before we proceed to our experiment, let us define first the following methods of separating mixtures. Magnetic separation is a method of separating mixtures based on magnetic properties of certain substances. Decantation is a separation technique used to separate immiscible liquids or a liquid from a solid mixture by carefully pouring off the clear liquid, leaving the denser or insoluble components behind. Filtration is a separation technique used to separate solids from liquids or gases by passing a mixture through a porous substance called a filter that allows the liquid or gas to pass through while retaining the solid particles. Distillation is a separation technique used to separate components of a liquid mixtures based on differences in their boiling points. Evaporation, as a separation technique, refers to the process of selectively removing a solvent, or usually a liquid, from a solution or mixture by converting it into vapor. Chromatography is a separation technique used to separate and analyze the individual components of a mixture based on their different affinities for a stationary phase and the mobile phase. Now that we know the different methods of separating mixtures, it's now time to see how it is done. Let's start with magnetic separation. I have a mixture of sand and iron filings here. Let's grab a magnet and try to separate the iron filings from the sand.
What did you observe?
Very good! The iron filings were separated from the sand because the iron filings were attracted to the magnet. In this process, materials with magnetic properties are separated from non-magnetic substances. The key principle behind magnetic separation is that some materials are attracted to magnets while others are not. Let's move on to the next one. This time, we will be separating a mixture of coconut milk and bits of grated coconut meat. We call this method filtration. In this process, we will be using a filter, which is the strainer, as a tool for separating the components of this mixture.
What did you observe?
Very good! The strainer was able to separate the coconut milk from the grated coconut meat. In filtration, the filter acts as a barrier, preventing the passage of larger particles and allowing only the smaller components to pass through. This time, we will have decantation. We use decantation in our kitchen, especially when we cook rice. We will first wash the rice with clean water. Now, we have a mixture of rice and water. Now, watch as we use decantation in this everyday process that we use to cook our rice.
What did you observe?
Very good! With decantation, we pour out the water, and what is left in the container is only the rice. This process takes advantage of the difference in density between the components in the mixture. This time, let us see how evaporation is done. In our kitchen, there are times that our salt will become watery as it is already contaminated with water. The simple solution to this problem is evaporation. By simply placing the salt and water solution in a flat container and exposing it to the sun, evaporation will take place.
What did you observe?
Very good! The salt becomes solid and the water is gone. This separation method is based on the principle that different components in a mixture have distinct boiling points, and by evaporating the solvent, one can separate it from the solute or other components with higher boiling points. This time, we will see distillation as a method used to separate mixtures. In this experiment, we will again use a salt and water mixture, but this time, the desired substance is the water.
What did you observe?
Very good! Water was separated from the salt mixture using distillation. This process involves heating the mixture to convert its components into vapor and then cooling and condensing the vapor back into a liquid form. Distillation takes advantage of the fact that substances with different boiling points will vaporize at different temperatures. For our last activity, we will be performing chromatography. In this activity, we will see the mixtures that make an ink.
What did you observe?
Very good! The substances that make up the ink were all scattered on the paper, showing its different components. This method relies on the principle that different substances in a mixture will interact differently with the stationary and mobile phases, leading to varying rates of movement and separation. Congratulations! You have seen different methods of separating mixtures, and some are even used in our day-to-day life. We We are done with the lesson on the methods of separating mixtures. Let us see if you have learned something today by matching column A with the right method of separating mixture in column B. Were you able to answer the questions correctly? Very good! Congratulations on making it, and I hope you have learned something from me today. We will end our lesson here. Remember that learning science is always fun. It leads you to discover things beyond your imagination and to think with endless possibilities. Once again, this is Teacher Demi, your chemistry buddy.